So friends, welcome back to second part of Forja Chuck video tutorial, and in this part we are going to model the remaining parts of this assembly. Okay, so first let's model this part, jaw. Okay, so I will go to insert, new component and new part. Select this part, rename it Joe. Okay, now you can see that there are teeth on this part here, but I'm not going to design these teeth. They are not very important part of the detail. Okay, the important details are this construction, and there is a tapping here of 16 into 4 pitch square thread. Okay, and there is another tapping here, M14. Okay, so this is more important than these teeth if you ask me. Okay, so uh, first let's draw this profile and extrude it 38 mm symmetrical. Okay, so I will select front plane. Let's select right plane and sketch. Okay, let's draw the profile like this. Okay, now dimension it 51. Okay, the complete length this is 19, 32 and 32. Okay, and this is 19, this is 35. Okay, so let's extrude it. Extrusion 38 mm. Okay, so extrude it 38 mm mid plane. Click OK. Now there is an important detail here. You can see that there is a cut here, 45 degree. Okay, and 16. Okay, so let's make it. These radiuses are not important. These are for the teeth here. Okay. 16, 45. Okay. We can use chamfer command also. It will be like 38 minus 16 will be 22, and half of 22 will be 11. So the dimension from here to here will be 11. So I can easily use chamfer command. And one more thing, since the angle is 45 degree, it will be in isosceles triangle. Okay, so two sides are going to be equal, so it is easier to calculate. So I will input a value of 11 mm, select this edge and this edge, click OK. Let's measure this. This should be 16. Okay, 16. Okay, now there is an extrusion here, 22. Okay, select this face, sketch, draw a center point rectangle like this. Make the center coincident on the vertical to the origin. Okay, and the dimension of the center is From this to this is 28. Okay, and this is 25. There is something wrong. There should be no, maybe accidentally we created some relation we didn't want it, not equal length relation. Okay, and this is 22. Extrude it 26 mm. Okay, and select this face. Now we are going to draw this tapping M14 into 32. Okay, so I am assuming it is at the center of this part. So draw a diagonal and draw a circle here 14 mm. Extrude it 32. Okay, now this is a tapping, so we have to create threads on it. So select this edge, ISO M14 up to next, click OK. There is a dome here, but that is not very important if you ask me. The dome is not important, so I'm not going to draw it. If you want to, you can easily use the dome feature and create a dome here 1 or 2 mm. It's totally your choice. This detail is not important. Okay, so the next is the square thread here. Okay, since as I told you earlier in all of our video tutorials that there the square threads are not like cosmetic threads, so we cannot model them like this, so we have to actually design them. So I will select right plane and sketch. Okay, now draw a line from this point up to this. Okay, and the distance should be 13 mm. Okay, make it coincident here, this line. Okay, okay, this 13, this is the center line of the this hole. Okay, okay, so 16 minus 4 will be the 12 mm, so 12 mm will be the minimum diameter. So let's create a hole here 12 mm. Let's create a Pierce relation between this line and the center point of the circle. Features, extruded cut up to next, click OK. Now select right plane, sketch, and now we have to draw the profile for the square thread. I will draw a rectangle here and select all the edges, create an equal relation. Okay, now the distance from here to here should be 8 mm, and this should be 2 mm. Okay, wait a second, let me edit this. Make it 36. Okay, it should be multiple of 4. You can make it 32, 36, but it should be more than this. Okay, more than this face here. Okay, Now go to swept cut, select this rectangle as the profile and this line as the path, and the length of this line was 32. So 32 divided by 4 will be 8. So we have to give 8 revolutions here. Okay. Keep in mind that these should be right-handed. Okay. Click OK. Okay. So this part is complete except the portion of the these knurls. Okay, these teeth. But let me tell you again, these are not very important. We can just create a triangle here, extrude it up to this face, and make it linear pattern or sketch driven pattern, curve driven pattern. This is not very important here. Okay, so let's go back to our assembly. Float this part and move it here. Okay, so the next part is the, let's see, the washer. Okay, the washer is easy to design, so let's make this washer. Let's open this part. Okay, this is a square here, 4432 by 10. Okay, so I will select front plane, center rectangle, (32), 44, and let's extrude it by 10. Okay, and there's a boss square 25 here also. Select both of these edges and create an equal relation 25 mm. Extrude it by 2 mm. Now select this face, sketch, and we have to make a cut of 15 mm. I can also use hole wizard. Go to drills and 15 mm. Okay, select this face and click OK. So this part was very easy to do. Make it float and move it here. Okay, so the next part is the I'm not going to design this Hex Nut M14 right now. Maybe I can find it in the design toolbox, but I'm not sure because M14 is not a standard size. Okay, so the next part is this screw. Okay, insert new part. Okay, this is fairly easy, if you ask me. The thread size is not mentioned here if you ask me, but it is easier to understand that this part is inside this jaw, so the thread size is going to be same here as here, 16 into 4. Okay, So we have to uh, okay, the dia here. Okay, this dia, I don't know what is this dia. We have to find it also. But if I am right, it should be the minor diameter of this thread, okay, which will be 12 mm. Okay, let's see. Uh, Front plane. I can just revolve this part. Okay, so front plane, sketch, draw a center line like this. Let's create the profile. Wait a second. I can make it easily by just extrusion. Create a sketch on top plane, and it should be 12 mm. 12 mm because this is a tapping here, 16 by 4 here. So the minor diameter will be 12. 16 minus 4 will be 12. And let's extrude it by 64 mm. Okay, and in other direction let's make it 6 mm. Okay, this is because there are two dimensions, 64, 6. I'm going to assume this is the top plane from where everything starts. Okay, click OK. Now select this face and circle 25 mm, extrude it by 5. Now again a circle 13 mm, extrude it by 6 mm. Now there is a square 10 here. Okay, square 10 by 10. So let's draw a square here. Create equal relation between these lines and 10 mm. Extrude it 10 mm. This is outside. Let's fix it. I will select this face, sketch, and let's convert this edge. Extruded cut up to this face. Flip side to cut. Click OK. Okay. Now I have to draw the square thread. Okay. Select front plane, sketch, and draw a line from here up to this. It doesn't matter. It should be a multiple of 4. Let's say 76 here. Okay. Now again front plane, sketch, and draw a rectangle here like this. Make all sides equal, and it should be 2 mm. The distance should be 8. Okay. Now swept both base. Wait a second. Rebuild it. Okay. Swept both base. I forgot to exit the sketch before entering the sweep command. Go to options. Specify twist value. The length we selected was 76 and the pitch is 4, so the number of revolution will be 19. Okay, same threads, click OK. Now select this face and draw a big circle, extrude cut. Now again select this face, sketch, draw a big circle, or let's say 18 mm, and draw another circle here, 12 mm, extrude cut 6 mm. Okay, so this is the screw. Okay, let's go back to our assembly. Let's see if we have M14 in design toolbox. There is no M14 as I thought. Okay, so we will have to create a M14 nut. Okay, select top plane, sketch, and select the polygon tool, 6 sides, and create a polygon like this. Okay, now from this point, from this edge up to this edge, the dimension should be, let me check, for M14 it should be 22. Okay, create a vertical relation here, extrude it. Okay, and the thickness should be 11 mm. Click OK. Now select this face, sketch, for M14 the fine pitch is 1.5, so the diameter will be 14 minus 1.5, 12.5. Extrude cut it through all. Okay, now select this face and create a sketch, a circle tangent to the edges. Extruded cut, flip side to cut, draft 60 degree. Okay, let's make this mid plane so that we can mirror this cut extrude about top plane. Okay, now let's insert cosmetic threads here, M14 into 1.5. Okay, click OK. Let's go back to our assembly. We have all the necessary parts we needed. Okay, now we have to assemble it. Okay, so first let's rotate this part like this. Okay, if this part was fixed, you cannot rotate it. You first have to make this part float. Okay, now I know that this part goes inside here, so I can easily make it. Okay, So select this face and this face, coincident relation, okay, and this face with this face, okay, perfectly assembled here. Okay, now the washer goes here. Okay, so mate, select this face and this face. Okay, concentric relation. Okay, let's rotate this part, this face and this face, parallel relation. Okay, now let's bring in our hex nut. Okay, now the screw nut, this screw, sorry. Let's have a cross section. There are times when these kind of features fail. Okay, mate this face with this face. Okay, now we have a challenge here, how to mate this jaw teeth with this screw. Okay, you can clearly see that these are not very perfect here. Okay, so this is sometimes a challenge, sometimes not. Okay, so to do these kind of mates, we can use mechanical mates, but first for these let's open this jaw assembly feature tree and cut sweep and make this sketch 6 show. Okay, so I had made visible the sketch here. Okay, let's open this part and let's give this some color. Let's say red color. Let's repeat the same process for the screw. Let's give yellow color. Okay, some bright color so that these are visible. Okay, so okay, it is something like this. Now if I'm right, if these parts these two rectangles mate with each other, these, so we can easily say that this thread will be perfectly meshed because one is cut and one is sweep. So I will just create a mate between these two. So maybe some face was selected. Select this edge and this edge. Click OK. That error was because there was zero thickness for the threads. If I try to section it, it will show a error. So the best way to do it is section, and here gives a offset of 0.01. Click OK and it will work. So these are some kind of hacks. Okay, so you can see that we have mated these, and now I will delete this mate because I don't want this coincident mate. Let's suppress it, and now we have to add a screw mate. So before adding that screw mate, let's select both of these parts and isolate these two parts. Okay, I don't want any other part here. Okay, and mate here, go to mechanical mates, screw, distance revolution, make it 4, and for selection it is easy. I can select, we have to select the interior face, internal face of, okay, first I will select this face and then this face. Okay, click OK. Let's see if this is working fine. No, it is not working fine. So let's reverse the screw direction. Wait a second, it should be 4. Let's try again. Okay, as you can see that these threads are going totally perfect. So we have successfully created a screw mate here. Okay, let's hide these sketches. Okay, but we still have a challenge here of the distance. Okay, so because this face will have contact here and at lower area also. So first let's see the minimum distance. Okay, I will select this face and let's select this face. No, not like this. Let's select this face, this edge, and this face. Okay. Okay. Okay, wait a second. These screws are again. Let me check. Let's unselect it. And this washer mate, let's disable it also. Let's unsuppress the screw mate and okay. We'll see how to do it. There are many ways here. Okay, for example, I will move it here and let's okay, let's see, this is the maximum position. Wait, let me show you one more trick. You can go to move components and here free drag. Okay, collision detection and between these two components. Okay, and I will click on resume drag and let's change it to physical and the moment it touches it, it will stop. Okay, and we don't even have to create a mate here. But before it goes inside, it has already gone. There is a interference here, so let's move this part down and physical dynamics for these two parts, resume drag, and because there is a actually there is an interference between these teeth, so it will not work here if I'm right. Let's okay, but this is not a problem here. Okay, if I'm right, it should be 0 here, and let's go to circular component pattern, and let's select all of these parts. Okay, about this face 4 times, click OK. So when you move one part, all the parts will move. Okay, but we have to still decide the maximum position. So I will keep moving it down, and if I'm right, this will be coincident here, and before it will be coincident here, this part, okay, this washer will be coincident on this face here. Okay, so let's check it with physical dynamics between this part and this part, resume drag, and sometimes these features fits. Okay, sometimes not. So we still have to decide how much the maximum and minimum distance we have to give. So let's measure the distance between this face and this face, 41.46. okay, let's say 41.5 mm. Okay, so I will go to mates, advanced mate, and distance mate. Before selecting distance mate, the best way is to select this face and this face, and then go to distance mate. Okay, and change the minimum to 0. Click OK. For maximum, let's make it 41.5. Okay, let's try to rotate, let's try to move this part. Let's see how much it, okay, it stopped right when it touched the screw collar. Okay, and let's move it downward. It stopped right when these two parts had interference. Okay, came in contact. Okay, and when I show you in this, you can clearly see it working. Okay, you can make a video of these this motion also. It will not be a difficult one. Okay, let me show you the assembly with the jaws I have created. Okay, if you want to create the teeth, the teeth are not very difficult. You just have to pattern some regular drawn sketches here. Okay, so this was the profile, this was the part I created first. Okay, it is similar. There are no differences. Okay, so thanks for watching this video tutorial, and if you liked this video tutorial, give me a like and subscribe to my channel. I will be back with more video tutorials for you to follow. Okay, if you want this drawing, you can go to my blog. I have added the link in my description of this video. You can also download these drawings from my blog or from our Facebook page. I have added link to. If you still have any problem, you can add a comment on this video, or you can contact us on our Facebook Mechanical Machine Design page. Thank you for watching this video tutorial and have a nice day.